In the previous set of videos, we talked about the various factors that affect equilibrium. In this one, we are going to be talking about ionic equilibrium in solution. So, ionic, what does that mean? Or rather, the word ionic is obviously, it relates to the word ions, and you have two different kinds of ions, that is, a cation and an anion. And honestly, I remember the word cation from this meme where it says, since a cat has a paw, so it is positive. And an anion is negative, negatively charged. So, why does this matter? Let's think about distilled water. Okay, I know it's like a completely different thing from what we were just talking about, but distilled water is not able to conduct electricity. However, when we add sodium chloride to it, it will be able to conduct electricity. In fact, the amount of sodium, like more is the amount of sodium chloride added to the water, more is the ability for it to conduct electricity. And why does that happen? Right? Like pure water is not able to do it, but when you add sodium chloride to it, it is. It is because of the formation of ions by sodium chloride. Okay, so when sodium chloride is present as a solid, it actually doesn't conduct electricity. Okay, but when it gets dissolved in the liquid, something's happening, and that in turn leads to the conductivity of the liquid. So when you have sodium chloride, what happens is the water molecules come and try and break the bond between sodium and chlorine. Leads to the formation of the cation and the anion. Okay, and this is happening because the bond between sodium and chlorine in sodium chloride is ionic in nature. So the water comes and breaks it. This leads to the formation of sodium and Na plus and Cl minus, and these ions are helping conduct electricity. And if you remember, I'm pretty sure you've learned in physics, conduction is basically the movement of ions happening in the solvent. In case of a solvent as such, it's like movement of the electrons, if I'm not wrong. So sodium chloride is forming ions. Okay, in our solvents, in water or any solvent, when a particular substance leads to the formation of ions, there has to exist an equilibrium between the two. So, in the next couple of sections, we will be discussing the various systems which have ions in them and how the equilibrium is related to the whole situation over there. Michael Faraday was the one who classified substances to two he called them electrolytes and this line is so cross, sorry. Okay, I'm just going to write it much more neatly. So he classified substance again it's cross, anyways, substance to electrolytes and non-electrolytes. Okay, electrolytes are substances which are able to conduct electricity in a molten state or aqueous form. Example is sodium chloride. Sodium chloride is able to conduct electricity when it's in the aqueous state because of the formation of ions. On the other hand, non-electrolytes do not conduct electricity when they are in the aqueous state or in the molten state, and the example can be sugar. So sugar does not lead to the formation of ions, and so it's a non-electrolyte. It just gets dissolved. And if you think about the structure of sucrose, it consists of covalent bonds. So feel free to look it up. I'm not going to draw it over here. It consists of two I think you learn it in class 12, the structure of sucrose, but essentially it does not dissociate for us to get ions. It's not forming ions, and because of that, it's a non-electrolyte. Electrolytes, on the other hand, are forming ions, and because of that, they're able to conduct electricity in their molten state or in the aqueous solution. Electrolytes, so Basically, electrolytes are also further classified into two: strong electrolytes and weak electrolytes. So what do you think is the difference between the two? Strong is able to ionize to a great extent, whereas weak is not able to ionize to in aqueous solution to a great extent. Which so KOH, NaCl, H2SO4. Weak electrolytes examples can be CH3COOH, NH4OH. So what does all of that mean? Ionize. Ionize is basically the splitting of the substance to give us ions. Okay, so KOH will give us K plus, OH minus. NaCl is giving us Na plus, Cl minus. H2SO4 is giving, if I'm not wrong, H plus and HSO4 minus, or I think it's H plus and SO2 minus. I might be wrong in case of this one. Basically, it's able to split to give us ions. On the other hand, weak electrolytes will split, but they don't do it to a great extent. Like CH3COOH likes to exist as CH3COOH. It does not want to exist as CH3COO minus and H plus. NH4OH is the same. It does not want to exist as NH4 plus and OH minus. It hates doing that. And so it prefers to stay together. And so they are weak electrolytes. Strong electrolytes don't want to stay together. They want to separate to give us ions. And so they are strong electrolytes because they are able to conduct, basically they are able to help facilitate the conduction of electricity in the aqueous state. So if you notice, I've used two words. I think I've used more of this word, ionization, which is, so there are two words that you need to know about. One is called dissociation. The second is ionization. Honestly, both these words are going to be used interchangeably. There is a very slight difference between the two. So in case of dissociation, the example over here for dissociation is sodium chloride. So in case of sodium chloride, the ions are present as is in the solid state. And when they dissolve in the solution, these ions are going to dissociate. So they're getting split. Ionization, on the other hand, for example, hydrochloric acid, HCl, right? When it's in the I think it's usually in the gaseous state, but when we dissolve it, it gets dissolved in water to give us hydrochloric acid. So, when we have a neutral molecule like hydrochloric acid, when we put in water, it is leading to the formation of H plus ions and Cl minus ions. So there, it is getting ionized. So the main difference is dissociation, the ions are in the solid state, and when they're dissolved in a solvent, they're getting split. Ionization, on the other hand, is when ions are split, it's in neutral state as a molecule, but when it's introduced to a solvent, it gets split to give the ions. But remember, both these terms can be used interchangeably, and that's what is going to happen. I would definitely land up using more of ionization than dissociation. So I hope all of that made sense. So we started with what's a cation and anion. Remember, cat has a paw, so it's positive. Credit to all the memes that exist for this particular thing. So substances, basically, they're in the solution. There is the formation of ions by certain substances, and these substances, there is going to be an equilibrium between the ions, and we will be talking about such equilibrium in the next couple of sections. Substances are classified according to Michael Faraday as electrolytes and non-electrolytes. Electrolytes, when they are dissolved or in their molten state, they can conduct electricity. Non-electrolytes do not want to conduct electricity in their molten or dissolved state. Electrolytes are further classified into strong and weak. The easiest way you can remember is strong electrolytes lead to split and form ions, and these ions help conduct electricity. Weak electrolytes do not want to split, and so they lead to they're not going to be able to conduct electricity to such an extent as the strong electrolytes. We also talked about the terms dissociation and ionization. Dissociation is when you have a solid substance which has ions in it, and when you dissolve it, it gets split to form ions. Ionization is when you have a neutral at molecule when dissolved in a substance gives us ions. And both of these terms are going to get used interchangeably for the rest of this chapter. I hope all of this made sense. In the next video, we are going to be talking about what happens when we dissolve sodium chloride in water.